All right, guys, so I'm going to look over a few things on this magnetism worksheet to help you out while I'm gone. So number one says, what are the two criteria necessary for a substance to be considered a magnet? So one of them is it needs to have aligned domains. So that's those clusters of electrons that are all spinning the exact same direction the entire time. So not everything can be magnetized. And the second thing is it's going to be magnetic moments. So that is when we get an unpaired electron that's spinning around in one direction. It creates a magnetic field because we said that magnetic fields are created by moving charges. Well, an electron is a charge. It's moving, it's spinning, and so it creates this magnetic field. And when we get them all spinning together in aligned domains, it causes it to have magnetism. So, for an example, for number two. So state where you will see repulsion or attraction between them. So we're going to use R for repulsion, A for attraction. So alike repel, opposites attract. So between here and here, these are both alike. So we're going to get a repulsion. Okay, so I'm going to let you do that side. Now, down here it says draw a magnetic field for each of the following examples. So we did this in lab on Friday. Okay, y'all sprinkled the iron filings. You got to see where the magnetic fields lined up. And so that's what you're going to do. Now, I'm not going to have you draw real super complicated like I did on the lab. I just want you to indicate and then indicate with an arrow also the direction it's going. Now, I told you that it flows from the north to the south, right? So it goes from the north and into the south. So you do the same thing over here, okay? It comes out of the north into the south, okay? So that's when we drew those arrows when it came like this. That's what it did. We drew the little lines on your lab, okay? So you're going to do the same thing here, out of north and into south. Now, it's also, since these are opposites, they're going to attract to each other. So we're going to get some of this attraction going this way, okay? Broke my lead. Look at that. So sad. Okay, so we're going to get attraction. So I want you to sketch the rest of this too. Okay, and then you're going to do the examples between here and with the third one. Okay, well, obviously out of north into south, so we're going to get some attraction that looks like this. Okay, and I'm going to let you sketch the rest of it along from the north to the south and so on. Now, for number 4, it says, in the circles below represent compasses. In each situation, draw a needle of the compass using an arrow to show where it's going to point. So this is like on the lab when y'all drew the arrows on your magnetic field lab when I had you sketch those arrows by moving the compass around. So it's the exact same thing. So north, is it going to point towards north or away from north? Okay, it comes out of north, so the north pole of the magnet is going to repel the north pole on the magnet. So the north pole on the compass is going to point away. So you're going to do the same thing for here. Now, on this one's going to be kind of tricky. It's not going to point away from it if it's the north pole of the magnet is going to point towards what? Think about that. It wants to point towards what? The north or the south pole. So on this one, use your better judgment and tell me where you think it's going to point. Is it going to point towards the north or is it going to point towards the south? Okay, for number 5, it says a soft iron rod is magnetized with a magnetic bar magnet as shown in the diagram below. Identify the poles on the iron rod. So you're going to write north and south on these, okay? Well, if this is south, what's going to be attracted to it? So I just want you to indicate by writing it next to it, north and south on each end, whichever one it's supposed to be. Number 6 says draw the position of the needle in each of the compasses placed near the magnets or the wires illustrated. So once again, you're going to do like we did on the lab. You're going to also, or back like you did on number 4, you're going to indicate the direction that the compass is going to point. Number 7 says, which of the illustrations below is an accurate representation of the magnetic field? So look at A and B and tell me which one you think is correct. And then circle that answer, A or B. Okay? Number 8. This is Maria sprinkles iron filings on a piece of cardboard placed on top of a bar magnet. Which configuration will the iron filings make? Okay, so this is just like the lab that we did on Friday. So tell me, indicate which one you think is correct. And then last page, number 9, it says a magnet is surrounded by a magnetic field, which is shown by lines of force. Which one of the following diagrams correctly represents the magnetic field line? So think back to when we drew or we did our lab on Friday where we sprinkled the iron filings. Which one is correct? And then number 10, which of the following diagrams correctly show the direction in which the compass needle would point? Okay, so just tell me which way it's going to point, which one's correct, circle your answer. Okay, hold on to this paper till I get back so we don't lose them. Number 11, okay, it says among the diagrams, which is correctly the magnetic field. So think of those iron filings again. Which way does it flow? Remember that magnetic field flows out of the north into the south. So keep that into mind and circle the one that's correct. Okay. Excuse me. Number 12, 2 magnets are placed end to end. Which diagram is correct? So once again, just go through here. Tell me which one's correct. Look at the flow of the magnetic field. Circle the correct one. And then on 13, a magnet creates what is known as a magnetic field. A compass can be used to show that magnetic field. Which of the following statements are true? So if I break a bar magnet in 2, each piece will only have one magnetic pole. Like poles repel each other, the needle of a compass is a small magnet. So circle what is correct. Okay? Once again, hold on to this paper until I get back. And then you'll turn it in on Friday when I return.